Let's take a look at the third heat equation problem that we're going to solve today. All right, so problem 3 says a sample of water was cooled from 34.9 degrees Celsius to its freezing point, releasing 3,940 joules of energy. Notice that this is different from the previous problem. This is being cooled, so when you cool water, it releases energy. When you heat up water, it absorbs energy. All right, so it released 3,940 joules of energy, and they want to know how much water was there. What was the mass of the water? One of the things they're having us assume in this problem, I'm telling us, is that it's going to its freezing point, but it's going to stay liquid water. It's not going to turn into ice for this problem. So looking at our reference table, we're going to avoid the heat of fusion and the heat of vaporization. So once again, we're on our Q equals mc delta T equation. Q is equal to mc delta T. Once again, we're going to put in all of the numbers we know from the problem. So do we know Q? Q is heat, which is measured in joules. So yes, we know 3,940 joules. Do we know M? M is the mass of the water. No, we don't. That's what they want us to figure out for this problem. Do we know C? C is the specific heat capacity of liquid water. Yes, we do. We always know C. That is 4.18. And do we know delta T? Delta T is the change in temperature. So the water is going from 34.9 to its freezing point. The freezing point of water in Celsius is 0 Celsius. So this is dropping by 34.9 degrees Celsius. Okay? So once again, putting in all of those equations gives us a nice simple equation that we can solve for M. Our first step for that is we're going to multiply 4.18 times 34.9. So 3,940 is equal to 145.882 times M. So to figure out what M is, we're just going to divide both sides of the equation by 145.882. All right, and 3,940 divided by 145.882 is equal to this. All right, so M is equal to, how many digits of precision should I have for this problem? Well, I think I should have 3 digits of precision, because there are 3 digits here, the 349 and the 394, 3 digits of precision in this number too. That 0 doesn't count. So expressing this into 3 digits of precision, we're going to write that as 27.0 grams. It's the same as 27 grams, but by writing it as 27.0, I wanted to let you know that I'm rounding that to the nearest tenth of a gram and not the nearest gram. So it gives you some idea of how close it is to exactly 27 grams. All right, so I hope you're getting a sense for how the heat equation, Q equals mc delta T, is something that you can solve for any of the variables if you have all the other variables, just by having a little reference table like this and remembering the specific heat capacity of liquid water. In the next problem, we will take a look at problem 4, which is a little bit different.